this sigma notation. The part on top, you guys will get, excuse me, you guys will get a number on top. Okay? You guys will get a number on the bottom. The number on the bottom is my starting value. And that's my starting value. The number on top is the ending value, the number I'm going to end with. And I know this doesn't make any sense until I actually do a problem. That's my ending value. Whatever number is on top, that's the number I'll end with. And then here, you see some function that we're going to plug into. All right, so that's going to be our function. All this is a bunch of substitutions. That's all this is. Substituting in a number, what do you get? Substitute in a number, what do you get? All right, let's jump right into the fire here. Number one. Does everybody see I got a number on the bottom, number on top, and a function? All right. Starting value is 3. So you start by plugging in the number 3 to the function and tell me what you get out. Okay? So you start by taking k equals 3, plugging it in for k, and tell me what number you get out. We got to use the calc for this. 2 times 1? 7. Everyone all right? I don't think we need the calc, do we? What's my ending value on top? 8. So here's what we're going to do right now. We started by plugging in 3, and we're going to plug in all numbers between 3 and 8 right now and get out another number. All right, so I plugged in 3. Guess what the next number I'm going to plug in is? 4. Go ahead, plug in 4 for k. Let me know what number you get out. End up getting 9. You're building a sequence now. All right, you're starting to build a sequence. You plugged in 3, you plugged in 4. Now I'll plug in 5. Go ahead, plug in 5, and I get, oh, I'm building a sequence, particularly an arithmetic sequence. Keep going. Let's find the rest of the terms in this sequence. You plugged in 3, 4, 5. Now plug in 6, and I get 13. Plug in 7, 15, and then finally plug in 8. And that is where you stop plugging in numbers, is that top one. Here's their sequence right now. Here's the difference, though. When I have the sigma, I want to know what they all add to. All the terms in this sequence add to. Okay, so when I see the sigma, I want to add all those terms I've just generated out. And it adds to 72. Get a confirmation on that? Okay. Not that I didn't trust you, Andrew. And that's it. That's my final answer for that sigma. What do you think? I don't have enough terms?
No.
You good?
Yeah.
And that's my final answer for that sigma, 72. So you generate all the terms in the sequence, and then at the end, I'm going to add them all together to get my final answer. All good? Okay, 1 doesn't make you great. Let's keep it going here. Next up, now you may need the calculator. I wouldn't blame you here. Starting value. 0. Plug in 0 wherever you see an n right now. So 2 times, in parentheses, 3 raised to the 0. Okay, here we go. Let's start asking some. $10. What do you got when you plug in 0? 2. Nice job. So 2. Now what am I going to plug in? Don't go right to the ending value. 0, 1. You plug every number in from 0, the starting value, to 4, the end value. So go ahead, plug in 1, everybody. I'm just going to ask a bunch of people right now. Plug in 1. 6. What do you get when you plug in 1? 6. Nice job. I plugged in 0. I plugged in 1. Now plug in 2 now, everybody. Plug in 2. Value I get when I plug in 2. Let's hear 14 when I plug in 2. 18, we're on fire. Plug in 3 and 4 now. I'll ask somebody for 3 and 4. What do you get when you plug in 3 and you plug in 4? Here we go. 8, what do we end up with? 54, 162. And again, because it's sigma, what am I doing to all the terms? Adding them all up. Yep, that's what the sigma tells me. Add up all the terms in that sequence. Let's not waste time getting 242. Question from you guys. How is number 3 different? I put a +2 in the front. Any idea what I'm going to do? Anna? Yeah, whatever these added up to, I'm just going to add 2 at the end. I am not going to add 2 to every term. Don't get confused with that. All I'm going to do is do exactly what I did, figure out the sum, and then at the very end, I'm going to add 2 to my answer. Go ahead. Compare it with your group when you're done. If you want to try number 4 as well, go right ahead. I'll start listing out the terms up here as you go along. You start by plugging in 1, end by plugging in 4. Ten, 7, 4, 1. And then remember, add 2 to that at the end, or you can put the 2 in there right now. It's up to you. 22. So you end up with 24. Only thing different with number 4 is now you got to plug it in 2 different spots. So everywhere you see a K, plug in 3 through 5 right now. Everywhere you see a K, 3 through 5. A lot of people are like, I can handle this. This isn't that bad, right? Just plug and chug. Okay. Sure. $12, $20, and $30 are your terms in the middle. And then add them together, we get 62. All good right there. I'm going to move fast now. All good, 62. Okay, you can check these on your calculator, and I'll apologize in advance. I knew that at the beginning, but I didn't want to show you how to use your calculator because I wanted you to understand where all these numbers are coming from. Everyone grab your calculator. Somebody quickly, which one do you want to check real quick? 2, 3, or 4? 4, okay, here we go. We'll check 4 and make sure it comes out to be 62. All right, you have a sigma button on your calculator. This is what I asked everybody at the end of class yesterday. If you go alpha window, you will see that sigma button. Okay, everyone see alpha window. Everyone see their summation E button there. Mine's choice 2. Most of you guys should be choice 2. And then look at that. It pops it right up. And all you have to do is plug in everything there. Okay, so what variable did we deal with in number 4? K. So you find where K is, and K is right above what, the parenthesis there? Yeah? Okay, so K equal to, what was our starting value? 3. Up above, you got 5. And then inside the parenthesis, the entire function needs to go inside the parenthesis. So k squared, so alpha parenthesis squared plus k. All inside that parenthesis, nothing on the outside of it. There you go. Okay, not bad. Now, hey, from now on, do I expect you to list out all the terms for me? Absolutely not. Plug it in your calculator. Go ahead. You got it in front of you. Why not use it? But there's going to be a problem where your calculator won't help you out. Okay? Look at the next problem. Somebody tell me how this is different than, I know it's got 4 plus. That's not the difference. Anybody see how else this one is different than the other 4 that we've done? What do you got, Matt? Yeah, darn right. There's another variable. And unfortunately, your calculator can only do these when there's one variable. Okay? So please remember that. Your calculator can only get you the answer when there's one variable, not 2. Guys, this is why I showed you how to do these. All right? By hand. All right? This is why I showed you how to do it by hand. All right, let's take it one step at a time. Ready? We'll add 4 at the end, right? If you want to put it in now, put it in now. It's up to you. All right, but we got to add 4 at the end to whatever I have. So put it in now, put it at the end. I don't care. What's my starting value? 2, right? So I start plugging in 2, but for what variable? K. X is staying X. I'm not plugging anything in there. So it's going to be 3 times 2 minus X. Go ahead, distribute the 3, and I'll end up with 6 minus 3x. So there is the first term. Now what number do you want to plug in? 3, 4, again, what variable? K. 3 times 3 minus x. Distribute, write out your second term. Plug in 4 now. And finally, plug in 5. And there it is. Now you just got to use your calculator, combine every like term that you can for me. I'll ask somebody in about 15 seconds what they ended up with. Okay, we end up getting what here? 46 minus 12x. Questions from you guys? Going. Okay, how many variables in number 6? How many variables in number 6? 2, right? An A and an X, so no calculator here either. It's going to help us. This shouldn't be too bad, right? I only have to plug in 0 to 2. All right, what variable am I plugging in for? X. So here you go. Here's the first one. 3 minus 2a, all raised to the what value I start with? 0. Anybody know what anything raised to the 0 is? This is going to be a quick one, Declan. 1. So my first term is 1, everybody. Okay, now I'm going to raise it all to the first. This one's pretty easy, right? What's it going to be? 3 minus 2a itself when I raise anything to the first. Here's where we're going to have to do a little work right now. 3 minus 2a all raised to the second. I'm nervous. What are you doing there? I'm hoping you're not giving me 9 minus 4a or whatever. This has to be written twice and FOILed. Double distribute, whatever you call it. Okay? That's got to be double distributed there. Nine minus 12a in the middle, and then what are you getting for the n? Plus. Yep, there you go. Go ahead, combine your like terms. Let me know when you get at the end here. Combine your like terms. What'd you get when you add them all together? 3. What'd you get when you add them all together?
4a squared minus 14a plus 13.
And that would be choice 4. Can we handle these signals all right now? Can we handle them? Whether it be 2 variables or 1. 1, use your calculator. 2, we got to do it out by hand. Not a big deal. All right, last one then with the sigma. Can you guys find me which one produces these 3 terms? All right, adds them all up. This is all going to be on the calculator. All right, all going to be on the calculator. So first thing I want to figure out is what's all that equal to? So I can figure out which sigma it'll give me. All right, so let's go to the calc. 1 plus, and everyone knows where the radical 2. Here's where my concern is, which is, do you know where the cube root button is? Anybody know where the cube root button is? That's raised to the third. This is cube root. Little different, though. Little different. I always go under math, and everybody see it, number 4. Okay, math, number 4. So cube root of, what are we putting in there? 3. Yep. Okay, so I'm looking right now. You guys are going to go through each choice right now using the sigma button on your calculator and then figuring out where it comes out to be 3.856, da da da. Okay. Hey, hold on, though. Hold on. Stop. Or some of you start beginning, whatever. There's one of these you can eliminate right away. How many terms are up here, guys? 3. If you look at the starting and the ending value on one of the sigmas, you'd actually get out 4 values. Anybody see the sigma that would give us 4 values out? Choice 2. When you plug in 0 through 3, that'll give 4 choices, so don't even bother with 2. All right, save yourself some time. Go ahead and check the other 3 sigmas, though. See which one you get out that decimal we just had on the calc. Saved it to the very last one, huh? Any issues getting it to 4? All right, guys, that's one way you can add up a sequence is by putting in sigma notation. Now I want to focus these last couple problems for today on actually an arithmetic sequence. Okay, an arithmetic sequence. And I want to start using some vocab here. When you add up a sequence, it's called a series. Okay? When you add up a sequence, it's called a series. So we're going to take an arithmetic sequence, add it up. That's why I call it an arithmetic series. Look at my first example here. Find the sum of 12 plus 19 plus 26, so on, to 180. Somebody explain to me why that's arithmetic, first of all. Why is that arithmetic? 12, 19, 26, etc. Why is that arithmetic? Because I'm adding the same number every time, which is 7. Agreed? Okay. Do you think I want you to find all the values in between and then just add them up on the calculator? Absolutely not. Okay. There is a second formula I'm going to introduce now. The first formula, where is it located? On the reference sheet. That's that AN equals A1. Can you get out your reference sheet for me too, please? All right, get out your reference sheet for me. So we're all familiar with the arithmetic sequence formula we've been using the past 2 days. Okay. Does anybody see anything on there that says arithmetic series? I see geometric. Anybody see arithmetic series? I'm asking because the formula I'm about to put on the board is your responsibility. Okay, it will not. This is the only formula that you are responsible for this unit is the arithmetic series when I add it up. Here it is. Only one you're responsible for. All the others will be on the formula sheet. Started off with an S. For sum. Sum. That'll be how many terms. I'll label this in a second, but this is the sum of how many terms in an arithmetic sequence. Here's what it's going to be equal to. And I'll explain everything in a second. There it is. There's the one you're responsible for. Okay, ready? You already know what one of them. What's A1 again? First term. Yep, that gets plugged right into there. First term. A sub n, here you go. A sub n, that's your last term in the sequence you're adding. Last term. And here's the big part. N, that's the number of terms you're adding. All right. Okay, let's use it. Let's use it now because you're missing, I don't know if you guys see, but you're missing some information to plug in there. Fill in at least one of the values now. Fill in at least one of the values in the formula. Easily. One of the values in the formula. Here you go. One of the values in the formula. A1 is 12. There you go. Remember what A sub n is. That's the last number in the sequence I'm adding. Last number in the sequence. I provided that as well. What's that number? 16? 180. So 12 plus 180 divided by 2. What is the only value I did not give you guys? N, which is how many terms I'm adding up. Well, 1, 2, 3, oh boy, all the rest in the middle, 180. That's So how can I find the number of terms I'm adding up? Ready? You got another formula that we've used? All right, what's the other formula say? I'm going to get rid of this, all right, so I got some room to work. What's that other formula say? AN equals A1 plus. That'll tell you how many terms there are. What do you already know A sub n is? My last term here, what is it? 180. Ready? Watch. 180 equals 12 plus, how many terms are there? I'll find out in a second. Can you guys find the D value here? 7. Going by 7. You solve for n, that'll tell you where 180 is in this sequence. It'll tell you what term number it is. Do we all have the ability to solve for n? Yes, no? Okay, go right ahead. I'll give you a second. Whenever you're ready. 4, whenever you're ready, let me know. All right, perfect. Then we'll be here a while then, huh? 2, when you're ready, let me know. Distribute the 7. Combine like terms, get the n by itself. It is 25, yep. So that means 180 is the 25th term here. So I'm adding the first 25 terms. So I can write that as, hey, I'm finding the sum of the first 25 terms. N matches n, remember. And go ahead. What is the sum of all these now? When you're ready, 9. When you're ready, what's the sum of all these 25 terms? 2,400. Absolutely. 12. Okay. Anything you want to ask up there? Be prepared not to be able to fill in one of these. And how do I find that missing value? I use the formula we've used the last 2 days. All right, be prepared for that. Speaking of that, 9, here you go. Find the sum of this series now. N16, A sub n, 240, and D, 8. You're missing a value here, and we'll talk about what value you're missing right now. Oh, forgetting the n, sorry. What's my n value? N value? 16. So n, sum of the first 16 terms is equal to 16. You got the first term? That stinks. We'll have to talk about how to get that. So I'll just leave a blank. Plus, what's your A sub n term, your last term? 240 all over 2. Okay, again, how can I find my first term? Go back and use the formula that we've used, the explicit formula that we've been using the last 2 days. Okay, help me fill it in now because I got to solve for the first term. Help me fill this in. Here we go. 9, A sub n.
A sub n is equal to 240.
240, nice job, equals A1, which I'm trying to find, plus what's the n value in this problem? N value 18? 16? Got it. Minus 1, and how about the D value here? my common difference, what I'm going by. Here you go, 7, common difference.
Is 15 times
Oh,
well, 8.
8, there you go. Okay, everybody, solve for the first term now. Solve for the first term if you haven't done so already. First term, whenever you have it. First term, whenever you have it. 12, whenever you have it. $1.20, nice job. So I'll take that, substitute it in over here, $1.20. And I'll just do this for you. That sum, 2,880.
Just making sure that the 16 is over the fraction.
Correct, it's in the numerator. Yep, in the numerator. Yep. Anything? Okay, we'll end it on a word problem. Not too bad of a word problem. Okay, running marathons. Matt's going to run 20 miles the first week, 4 miles every week after that. How many total? That tells me some did he run in 8 weeks. Can you guys, again, anytime I see a word problem, I want to produce a couple numbers in the sequence. What's the first number in my sequence for this word problem? That's how many people ran, though, right? We're looking for how many total miles, right? 20. Next week? 24, because he runs 4 more every week, 28, so on. Now, desperate times, yeah, we could easily just plug, find all 8 and add them up. All right, but what if he's doing, 62 weeks? I don't know if anybody's going to keep doing that if they got time to do that. Okay, sum. Only formula you're responsible for. How many weeks? What's going to go in for n? How many terms am I going to add up? 8, right? So the sum of the first 8 is 8 n value. How many for the first week? 20. Plus, do I know how many he ran in the last week without doing it by hand? Nope, but what can I use again? The explicit formula, yep. And this is all divided by 2. Use your explicit formula. Just get used to that. If you're going to find the sum, you're probably going to have to use the other formula to find the missing part. What do you guys use? What are you guys finding here in this formula? AN, right, which is basically A8 for us. What's the 8th term? First term was 20. What's your n value? Matches. What did I just plug in? 8. And what are they going by? Yep. So this will show you how much he ran in the 8th week. $48 miles for Big Matt here, 48. So during his training, he ran a total of, I got 272.